we're looking at Module 4, Homework A, Tab 4, Part 3, Electric Potential Function at a Launch Point. So we are asked with calculating the electric potential capital V at the initial position of the P, which is located at the origin or center of the semicircle, due to the capital N charges arranged capital N charges arranged on the semicircle arc of radius capital R. Each of these capital N charges has a charge of lowercase q, and we need to find capital V. So the electric potential capital V at a point in space due to a point charge q sub I is located at distance r sub I let me rephrase that. The electric potential capital V at a point in space due to a point charge q sub I located at distance r sub I from that point is given by capital V sub I is equal to k times q sub I all divided by r sub I, where k is Coulomb's constant, q sub I is the charge of the I don't know how to really pronounce this, ith point charge, and then r sub I is the distance from the charge to the point where the potential is being calculated. Since all the charges are arranged on a semicircle of radius capital R centered at the origin, the distance from each charge to the origin is the same and equals capital R. This is true for all capital N charges uniformly distributed along the semicircle arc. The electric potential at the origin due to multiple point charges is the sum of the potentials due to each individual charge. The potential capital V at the origin due to the entire semicircle of charges is simply the sum of the potentials due to each of the capital N charges. Each charge lower q and distance capital R from the origin. Since the distance from each charge to the origin is capital R, the potential at the origin due to a single charge is going to be V sub I is equal to k times q all divided by capital R. The total potential capital V at the origin is the sum of the contributions from all capital N charges. So we can write this out as V is equal summation I is equal to 1, capital N on top, and it's capital V sub I is equal to N times k times q all divided by capital R. The total charge on the semicircle is going to be q equals n times q, as we found in a previous part. So we can express the total potential at the origin to be capital V is equal to k times uppercase q all divided by r. And this is correct for the expression of the electric potential at the origin due to the charges arranged on a semicircle.